We've got a histogram here where we've plotted frequency density against weight. Now let's just remind ourselves, frequency density is equal to the frequency divided by the width. If you were to have a grouped frequency table, you would get your histogram using this. Why do that? Because we've got unequal widths here, and so it will be misleading if you were just to plot the frequency. You have to plot the frequency density. So Zoe says there are fewer parcels weighing between 450 grams and 700 grams. That's over here. Then parcels weighing between 300 grams and 450 grams. That's over here. Now that kind of looks like it's true from the starting point because the bar is lower. However, we've got to remember this is the frequency density. It's not the actual frequency. We can't talk about the number of parcels by just looking at the heights of the bars. What we need to do is work back to the frequency, and then that's where this formula again comes in. If I rearrange it, I get that the frequency is the frequency density times the width. And actually that means that the frequency is the area of each bar. So that's what we need to calculate. Okay, so if I look at the 300 to 450 bar first, and if I want to get the frequency, it's going to be the frequency density, which in this case is 70, multiplied by the width, which in this case is 150. Sorry, I didn't quite have my calculator ready. Okay, and I get 10,500. For 450 to 700, I've got a height of 50, frequency density, and now the width is 250. And I get 12,500. So in fact, turns out there are actually more parcels weighing between 450 and 700 grams. So Zoe is incorrect. Maybe I'll just say that this is greater than 10,500. There are more parcels weighing between 450 and 700. I'm just going to stop there. I could say than 300 grams and 450 grams, but I think I've illustrated my point. Okay, the delivery company delivered 6,500 parcels weighing between 50 grams and 100 grams. That piece is missing from the graph. Complete the histogram to work out this, to show this information. So the frequency density is going to be this frequency, 6,500, and then I'm going to divide by the width, which in this case is going to be 50. Normally you do this using a grouped frequency table. They've just given us the numbers here. And we get 130. So now I can plot that. Okay, there we go. Finally, Zoe uses the histogram to calculate the number of parcels weighing between 200 grams and 250. So this here. Explain why Zoe's answer is unlikely to be reliable. When you have your histogram and you plot it like this and you use the area, you are basically using the fact that it's evenly spread. And this may not be the case. The weight of parcels is unlikely to be evenly spread. because we're basically assuming that half the parcels will be between 200 and 300 will be in this first section between 200 and 250, and half of them will be between 250 and 300. They could all be really close to 300. They could all be really close to 200. There's no way of knowing. So we're making an assumption here, and it's a decent shout for sure, but you can't really say it's going to be reliable. You can't say yes, it's going to be exactly that amount, and that's what this question is trying to get at.